Bismillahirrahmanirrahim. Today, inshallah, I wanted to talk about the y equals tangent of x graph, or the parent graph of the tangent function. So that's the topic of the day today, inshallah. We have previously talked about the sine and cosine functions, and the sine function, for example, was kind of looks like this, if you recall, and it's with its period being 2 pi, like this, as being 1 and -1, the amplitude being 1, and then the cosine function, if you recall, looked kind of like this, the cosine, the hammock type looking function, goes like this and went over here, and it was like that. So that was y equals cosine of x, and this was here y equals sine of x. Those were the parent functions for sine and cosine graphs. So the question then is, what does the y equals tangent of x graphs looks like? Okay, so that's what we're going to try to explore today. To do this, we're going to fall back to the unit circle. I'm going to label some important points. X is 1 and y is 0. Here x is 0, y is 1, and x is -1, y is 0, and x is 0, y is -1. And if you recall, this was 0, this was pi over 2, this was pi, and 360 degrees looks at 2 pi, and this is 3 pi over 2. And 45 degrees ends up being quite important to us, and that's pi over 4. And this point over here is -45 degrees, so that's theta is 45. If you recall, you can also go backwards with angles, and if this is theta, this is like negative theta. Going clockwise is backwards of the angle. And so this would be like negative pi over 4, right? -45 degrees. Okay, so that ends up being particularly important to us. And if you recall, for any given ordered pair on the unit circle, the ordered pair corresponds to cosine of theta and sine of theta, this being the theta. And so the x and y coordinates represent sine and cosine of theta. And for pi over 4, they were, if you recall, square root of 2 over 2 and square root of 2 over 2 over there. Now, another preliminary type of knowledge that we kind of need over here is that we have to understand that tangent of theta, or tangent of any particular angle, is sine of theta over cosine of theta. So the tangent is defined as a ratio of sine over cosine. Sine of gerene over cosine of gerene was tangent. So this is kind of like the background knowledge that we're going to need to be able to graph. So the first, the graph, the y equals tangent of x graph, is right here, our goal for today. Now, the first thing we would like to do is actually just calculate some tangent values of these important points that we have kind of generated. This one, this one, this one, this one, this one, and this one. And from there, try to extrapolate some this graph, okay? So, let's see. If you wanted to do this, we can just make a table, and we can kind of put some of these points over here, starting with 0, etc. So let's see what we can do. So let's start with 0 over here, like this. So tangent of 0 degrees, that's going to be tangent of 0, is going to be sine of 0 over cosine of 0 degrees, or in radians. Well, sine here is what? 0, right? Because right here we're talking about this right there. So sine of 0 degrees is 0, and cosine of 0 degrees is 1. So that is 0. Okay, So tangent of 0 degrees, now we're going to doing this in radians. So tangent of 0 radians is going to be 0. Okay, so we got our first point there. Now if you go to 45 degrees over here, pi over 4 over here, so tangent of 45 degrees is going to be sine over cosine, and they happen to be the same, so square root of 2 over 2 divided by square root of 2 over 2 is going to be 1. Right? So I'm just generating some tangent values of this one, this one, this one, and I'm going to go on like that across this unit circle to get us a feel for what this graph might look like. So we got the tangent value of this, we got the tangent value of that. Let's go over here to pi over 2 at 90 degrees, okay? So if you do tangent of pi over 2 or 90 degrees, that's going to be sine of 90 degrees. Okay, sine of pi over 2, right, over cosine. Sine is here 1, and cosine over here is 0, and we immediately recognize a problem. And the problem here is in the form of y here is 0, because you can't divide by 0, and that's wrong, it's super bad, and this is undefined. So undefined. And if you remember, when you get this undefined or problem, when you get this, it's like error, right? There is an asymptote in the graph usually. So here we have pi over 2, which is 90 degrees. Tangent is problem, like undefined, right? Undefined. Okay. And then if you go over here, right here, and it's going to be just a reflection of this over here, kind of like that. And except those y is positive, x is negative, so tangent is going to be the negative value. But instead of doing that, if you allow me the liberty, instead of going this way, okay, we are going to, instead of going this way, we're going to go this way, okay, also, okay? And just hang tight with me. Why are we doing that? You say, well, let's just hang tight with me, okay? So now, if we go backwards, now we have what's negative pi over 4 over here, like this, okay? That's going to be square root of 2 over 2, and y is negative square root of 2 over 2. So tangent is going to be negative 1. And then we get back over here, okay? Sine is this, cosine is this. So we have negative pi over 2, negative 90 degrees. And then again we have a problem, okay? Because sine is negative 1, cosine is 0. So tangent of 3 pi, negative pi over 2, or negative 90 degrees, is going to be negative 1 over 0, and that is undefined, okay? So what we see here is that there's going to be undefined value at pi over 2 and negative pi over 2. So if we go to the graph over here, those are going to be kind of critical points. So what I'm going to do here, now I'm going to graph this. I'm going to say this is in radians. This is pi over 2 right there. And this is going to be negative pi over 2 right there. And the graph is undefined in that area, okay? So I'm just going to make a big red line over there. That's an asymptote, okay? And then again here at negative pi over 2, that's an asymptote over here, okay? And so we are making progress over here. So I'll make it kind of reasonable here. Okay, now you have to be careful here because x here is actually theta, right? And this is y here is tangent of theta. You can't mix these x and y's here over here. And then you notice that you're going to have these asymptotes every 90 degrees. You're going to have it at pi over 2, and then you're going to have it again in 3 pi. So here, let's say this pi over 2, and this is pi, and this is again is going to happen again over here, right? Which is 3 pi over 2 right there. So this is 1.5 pi, right? And then this is 2 pi right here. This number over there is 2 pi. So again, at 3 over here, you're going to have another asymptote, right, like that. And then you go back over here, okay? And you're going to have another asymptote over here. So these asymptotes, as you can see, they are going to be recurring every pi values. So negative 2 pi. So they're going to recur every pi. Half a circle is pi, right? So they're going to occur every pi. So the asymptotes are going to occur every pi. So if the asymptotes occur at negative pi over 2 and pi over 2, they're going to occur at 3.5 pi, 4.5 pi, and 5.5, like that, okay? So this graph is going to have lots of asymptotes, okay? And there's going to be another one like over here. Look, another one over here if you wanted to draw one out. Like there's another going to be over here, okay? Now, kind of like that, okay? So now we're just going to focus on what the graph looks like in between these two, okay? So we're going to graph between negative half pi and positive half pi, okay? So when tangent of 0 is 0, that's over here. We got 1 point. Tangent of pi over 4, which is 45 degrees, that's pi over 4, that's 1. So let's call this, let's call this 1. Let's call that 2. And let's call this negative 1. So this is 1, and that's that. And then tangent of negative pi over 4, that's over here, that's going to be negative 1, like this. Okay. Now what's going to happen is, now what's happening to tangent between from here to here, okay? Between pi over 4, this value, and pi over 2, okay? So what I have done here, this is a review, okay? I've first appreciated that there are asymptotes here, because at pi over 2, this graph has an asymptote that's right over here, and I made an asymptote. And then I realized another asymptote over here, and then negative pi over 2. And then I realized the asymptotes are going to be recurring every 180 degrees, every pi degree, pi radians. So then you can have all these asymptotes that I have drawn. Some of them I've drawn, some of them I have not drawn like this, because I don't want to crowd the graph. So the graph is going to be a recurrent graph, okay? So then I have to focus my attention to just what happens to the graph from here to here, from the first graph, and then I'm going to extrapolate that to the fourth quadrant. So if you focus this on the first quadrant, let's see what happens to tangent. Now recall again, tangent is sine over cosine. So if you make this triangle over here, now sine represents the y value, and cosine represents the x value, right? So here's another triangle over here. Not quite accurate, but you get the idea. And then let's draw another one here. Correct. So so as you're getting closer and closer to pi over 2, which is over here, right? The y value is getting bigger, and the x value is getting smaller and smaller. Correct. So this value is going to get bigger and bigger and bigger, smaller, smaller, smaller. So this, in fact, will continue on and go to infinity. Okay. So going from pi over 4, which is right here, which is 1 right here, that's 1. And this graph is going to keep going. It will never reach the asymptote, and it will go kind of like this. Okay. And then on the other hand, over here, it's going to go, as it comes over here, it's going to go towards negative infinity for the same reason. As you get closer and closer to over here, the y value will get bigger, x value gets smaller, tangent will get to a bigger and bigger negative value, so to speak, like this. So this is the graph of y equals tangent of x, 1 period. Okay, so this is y equals tangent of, in this case it's theta, okay, but we're going to say x right here, and right here. But then this graph is going to recur, okay, and every pi interval. So again, it's going to do this again over here, like this, and it's going to come down here again towards this asymptote like this, and then again over here, like this. Okay, so y equals tangent of x is a very interesting graph, because it has like lots of asymptotes like that. Okay, now the key thing to appreciate here at least in my mind, is to understand that this graph is reproduced here and here and here and here. Okay, so if you understand the basic graph, okay, the parent graph, then you understand, you extrapolate that. So let's make some observations over here. Okay, first note that the period for this tangent graph is 1 pi. It's from negative pi over 2 to pi over 2. So the period is actually pi. It's not 2 pi. For sine, if you recall, period was 2 pi. For sine curves and cosine curves, the period was 2 pi. And for tangent curve, the period is only half as much. Okay, and if you can imagine over here, that kind of makes sense if you look at those graphs over there. Okay, so period is pi. It's not 2 pi. Period is pi. Also, there's like no amplitude here per se, right? Not like over here, because these graphs go to infinity. The concept does exist over here, and I'm going to elaborate that on the next video. But one thing that I would like to appreciate is that the period is pi. Okay, and this graph keeps repeating itself. Now this point over here is going to be our pseudovertex. Okay, I'm going to call that point right here, okay, the pseudovertex. That's going to be the Vx and the Vy. Okay, that's going to be at the origin, inshallah. So as a review then, this is the graph of y equals tangent of x, and it's a cyclical graph like this. It has a period of pi, and when you graph tangent graph, the basic graph is between the negative pi over 2 to positive pi over 2, and that's the graph, that's the parent graph, so to speak, that you're going to work with. The period is pi, okay, and the pseudovertex is at the origin right here, and we're going to call that Vx, Vy, and we will elaborate on that next time, inshallah. Until then, as-salatu was-salamu ala rasulillah rabbil alameen. Assalamu alaikum.